All right, welcome to the video for the solutions of paragraph number 1. So, we have a group of students preparing for a robotic competition, and they build a robot that can launch a large sphere of mass m in the horizontal direction with a variable speed from a variable vertical position. The robot's calibrated by adjusting the speed at which the sphere is launched and the height of the robot's sphere launcher. Okay, so they can vary the height and the speed. Awesome. Depending where the spheres land on the ground, the students earn points based on the accuracy of the robot. The robot's calibrated so that when the spheres are launched from a vertical position of y equals h and a speed v0, they consistently land on the ground target that's at a position d. So the positive direction for vector quantities are indicated. So before I get into this problem really looks like a projectile motion type problem where I have some type of motion occurring in the x direction and some type of motion occurring in the y direction. So in the x direction, my acceleration is 0, which means I'm moving at a constant velocity. Okay? So the only equation I can really use is x equals vt. And that velocity is represented by whatever the speed coming out of the launcher is. Okay? So then in the y direction, we're going some free fall motion type problem. So my initial velocity is going to be 0 in the y direction. My acceleration is a negative 9.8 meters a second squared. My change in displacement is a negative h because I'm falling downwards. And pretty much that's all I know. Keep in mind that with projectile motion, y direction is most closely related to time. So if I change something in the y direction, I change the amount of time that object is in the air. And that's going to affect how far we travel in the x direction. All right. So a group, we already read that part, duh. All right, so on the axes below, we need to sketch graphs of the horizontal and vertical components of the velocity as a function of time when the sphere lands, or launched to when it lands. Label t equals t for the horizontal component of the sphere's velocity and the vertical component of the sphere's velocity. Okay, so the horizontal component, remember, we already talked about, since the acceleration is 0, undergoes a constant velocity. Now, this object is traveling to the right, which according to the problem is a positive direction. So I need to have a constant positive velocity, okay? And I'm going to label this last point here as time t. The vertical velocity, on the other hand, is a different story. In the vertical vertical direction, we're undergoing constant acceleration. Now remember, the slope of velocity versus time graph is acceleration, so I need to have a constant slope. Not only do I need to have a constant slope, I need to have a constant negative slope since my acceleration is negative. Okay? Now, my graph also needs to start at 0 in the y direction because my initial y direction velocity is 0. So my graph in the vertical direction is going to look something like this. And again, I'm going to label this time t. Okay? So let's go ahead and check the scoring guide and make sure I get those points. So I get 1 point for sketching a horizontal line above the axis. I did that. And 1 point for sketching the line with a constant slope that begins at the origin and becomes more negative. I did that. And their example responses are pretty much exactly what I drew. So, naturally, there's a problem. When the students arrive at the competition, it's determined that the height of the sphere launcher can no longer be adjusted due to a mechanical malfunction. Therefore, the spheres must be launched in a vertical position of h over 2. Okay, so we've changed the height. We've decreased the height. Automatically, I'm thinking less time in the air. However, the spheres can be launched at a speed of v equals 0 not v equals 0, v0 or 2v0. Okay. So 2v0 will get me farther than v0. Now remember, this is a competition, and we want to get as many points as possible. So in a clear, coherent paragraph that can also include diagrams and equations, describe the speed at which the sphere should be launched so that the student earns the maximum number of points. Okay. Now, for an object that's in free fall, the time of flight from the position versus time equation t plus 1/2 at squared. These are all 0. Ends up being 2x over a. Or in this case, 2h over g. Okay? So if I cut h in half, okay, that's going to change t by a factor of 1 over the square root of 2, since h and t have a square root relationship. Okay? So it's not exactly cutting time in half. So doubling the velocity is not going to get me back to position D, but it is going to get me pretty close, which is exciting. Okay? So I'm not going to be able to get into the 4-point zone. Okay. But the thing is I'm also not going to be able to get in this 2-point zone, which is good. So cutting this t by square root of 2, if I then also double this velocity, my x changes by a factor of 2 over the square root of 2, which is somewhere in this 3-point zone. So I'm going to get in the 3-point zone, which is nice. Not 4 points, but it's better. Okay. So let's talk about this. So the students should launch at a speed of 2v0. So I've answered the question. Okay, now I need to explain why. So at h over 2, the sphere will have less time in the air. This directly decreases the horizontal distance traveled. In this case, the time changes by square root of 2. Because, or actually, no, that's not where I want to go next. Where do I want to go next? Okay, so I talked about how the time changes. I need to write 1 over the square root of 2. In order to make up for a decrease in time, the horizontal velocity should be increased to get as close to D as possible. However, the velocity can only be doubled. Be great if I could spell. So the new position will be at, or I should say the new landing position will be at 2 over the square root of 2d, which is in the 3-point range. Launching at V0 would not get the maximum points still possible. So I talk about why I want to launch at 2V, okay, in terms of variables, and then I also talk about how launching at V is not going to get me the maximum amount of points. So let me just read through this again and see if it makes sense. The student should launch at a speed of 2v0. At h/2, the sphere will have less time in the air, and that directly decreases the horizontal distance traveled. In this case, the time changes by 1 over the square root of 2. In order to make up for a decrease in time, the horizontal velocity should be increased to get as close to d as possible. However, the velocity can only be doubled, so the new landing position will be at 2 over the square root of 2g, which is in the 3-point range. Launching at v0 would not get the maximum points still possible. Let's say at this new height. All right, let's check the scoring guide to see how I did. So I get 1 point for a statement indicating that the sphere decreases the time. I did that. A statement that indicates that if the sphere is launched at the original speed, the distance traveled before hitting the ground will be x minus d, or x is less than d. I sort of did that. So I'm going to give myself that point. 1 point is earned for a statement that indicates that with a launch height of h/2 and a speed of either v or 2v0, the student can no longer earn 4 points. I mean, I said that they get in the 3-point range. So I'm not sure if I would get that point. So the thing with AP exams is they're read at a table. Okay, so when a person or grader has a question like this and they're wondering if a student should get a point, they usually put it up to the other people reading the question and they ask, would you give this response this point? Okay, so when put up to committee, they ask whether or not they would receive the point. And usually they err on the side of the student, but I'm going to err against myself and not give myself that point. So 1 point is earned for a statement that indicates that to get the most points, the student can no longer hit the quarter. They should aim for the 3-point zone. I talk about that. And I don't contradict myself, and I've written a paragraph. Awesome. So I've gotten 4 out of 5 points. As I've said before, you shouldn't be aiming for full credit on these paragraph responses because it's very difficult to be able to kind of get all of the things the AP exam is looking for. A lot of the times, the point that you'll miss is some random esoteric thing that you forgot to include. And it happens a lot, and it's okay. Okay, it's okay if you miss 1 point. That's not going to hurt your chances of getting a 5. And that's it for this problem. Have a great rest of your day.